This is the sixth lecture in our review of differential equations, and we're starting out discussing polynomials and properties of functions to just review some of the stuff that we're going to need further into the course. And today's topic, we're going to discuss the discriminant. And that's a big word, and it comes up when we're solving quadratic equations using the quadratic formula. So say we have a quadratic equation here, ax squared plus bx plus c is equal to 0, where x is the variable that we're solving here, the unknown, and a, b, and c are real numbers. Okay, so a, b, and c are real numbers. The formula, and we're going to look at this more into the next lecture, the formula to solve this we use is what's called the quadratic formula, and that is x is equal to the opposite of b, which is this middle term here, plus or minus the square root of that middle term squared minus 4 times the first term times the last term, divided by 2 times the first term. And this is what is known as the quadratic formula. Now, by looking at this formula and remembering what we discussed in the last lecture, you can see that the values of x are very important on this, what's going on in this square root right here. Okay, and there's 3 different things that what's underneath this square root, and what's underneath this square root is actually known as the discriminant. So the discriminant is b squared minus 4ac. That's all it is. So the value of b squared minus 4ac affects the solutions to this quadratic equation. So if the discriminant, which we'll call b squared minus 4ac, is greater than 0, then, well, what's going to happen is this square root is going to get simplified, and we're going to have this number plus whatever real number comes out of here, or this number minus whatever real number comes out of this, and then we're going to divide it by 2, divided by a real number. Therefore, we can say that if the discriminant is positive, then the equation has 2 unique real roots. 2 unique real roots. And if b squared minus 4ac is negative, what we learned from the last lecture in complex numbers is that this would be some real number plus an imaginary number, or this minus an imaginary number. So the equation would has 2 imaginary roots. And if b squared minus 4ac, there's another option. What if this is 0? Well, if this is 0, the square root of 0 is 0. And therefore, then x would just be negative b over 2a. And that's just one number. And we would, technically, we call that a double root. But it's just, the equation has one real root. And on another note that you can't really tell from this, but if b squared minus 4ac is a perfect square, a real perfect square, I should say, then the equation's factorable. You can factor the equation. if a, b, and c are integers. If a, b, and c aren't integers, then that's not the case. But if b squared minus 4ac is a perfect square, then we can factor this equation. So let's look at some examples to see what the determinant tells us. Here's example 1, the first one we're going to look at. And all I want to know is what the solution, what kind of solutions to expect. So we're going to look at x squared minus 5x minus 5 is equal to 0. So we can say that the discriminant, which is b squared minus 4ac, is equal to, well, the middle term is negative 5, so it'll be negative 5 squared minus 4. A is 1 because there's no lead coefficient there. Now this one is one that a lot of people miss. They forget about this negative sign. Be very careful because that negative sign makes a big difference. So b squared minus 4ac equals negative 5 squared, which is 25. And then a negative times a negative is a positive plus 20. And then 25 plus 20 is 45. So that is a positive number. It's greater than 0. Therefore, the equation has two unique roots. Let's look at another example here. 5x squared minus 7x plus 8. Okay. So again, we're going to find b squared minus 4ac. And b is negative 7 minus 4 times a, which is 5, times c, which is 8. So this is negative 7 squared is 49. Minus 4 times 5 is 20, and 20 times 8 is 160. And when we do the subtraction here, you see that we're taking a positive number and subtracting it by a bigger number, so this answer is going to be negative. It's negative 111. So we could say this equation has two imaginary solutions. Let's look at one more example here. Number 3. This is going to be x squared minus 36x plus 324. Oh, that's a big number there. Okay, so b squared minus 4ac is equal to negative 36 squared minus 4 times a, which is 1, and this is 324. Okay, 36 squared is 1096. And wouldn't you know that 4 times 324 is also 1096. And that is 1096 minus 1096 is 0. Now this comes up because this is a perfect square trinomial. And factoring is not something that we're really going to be looking into, but factoring is a way to solve these. And you notice it's a perfect square trinomial because this is a perfect square, and the lead coefficient here is a perfect square. So we could factor this also just to prove that it only has one real solution. The square root of 324 is 18. And if you double 18, you get 36. So this is also equal to x minus 18 squared is equal to 0. And from here you can see that using the zero factor property that the solution here is only 18. But it's 18 twice. It's what we call a double root, but it only has one real solution because the discriminant is 0. All right, that's going to close our topic on the discriminant. The next lecture, we're going to look more into solving quadratic equations and using some different techniques to solve them. and I look forward to seeing you then. This video has been brought to you by Math-Based Tutoring, and I will put the Facebook page on here, www.facebook.com/math-based tutoring. If you need affordable online tutoring, check us out, and I'll definitely see if we can help you out. I appreciate you watching, and we'll see you in the next video.